treatments. And to find your total, you do the sum of x squared minus g squared over capital N. So then once you find those two, you just take your between treatments and subtract that from your total. On this one, it's really nice. They give you the sum of squares for everything. So if you'd rather just find your sum of squares within, you can. I know I probably should have said that first. Sorry. But anyway, you just add up all the sum of squares, and voila, that is your... Gosh, what is it? That's your sum of squares, or yeah, your sum of squares within. Alright, so to find your sum of squares for factor A, I think we... Oh, no, we haven't talked about this. Okay. It's not... I mean, like, it's not super confusing. You have to... A is by row. So, when you're looking at this table, there's, like... It's like 1, 2, 3... I might have done this wrong. It's... Well, what I did is I added the top rows of both of them. So I added the top row of male and the top row of female, and then I added the second row of male, the second row of female, and the third row of male, and the third row of female. And that is how you find your... the numerator. So basically it's all the numbers of the top rows added together, squared, divided by n. No, you know what, I'm not entirely sure how to do this. I will definitely ask Coke. Like, the problem is I'm not entirely sure what n would equal. I mean, like, I guess if you're adding all of the rows together, like if you're adding 0, 9, 9, 5, 11, and 17, you would be having your n equal 3. And I set mine equal to 6, so that might be why my numbers... Well, it would make my numbers bigger. But anyway, if you're doing that, which I think you're supposed to do, I think I did it wrong. You want your n to be 3, because you are just going across in rows. I really don't know. Whatever makes sense, I guess. So then the same thing for B. You add up each column. So if you add up all of the columns, so 0, 0, 4, 5, negative 1, and 3, then your n is going to be 3 because you're only doing it 3 times. So hopefully, that's how that works. It's hard to tell, honestly. Anyway, that's how you find A and B. So A is rows, B is columns. And to find your A-B interaction, you're going to add A and B and subtract it from your between treatments. So, hopefully you got them right. So yeah, I'm going to ask Coke tomorrow because I honestly, I don't know. I hope that I told you right. I don't know. So then, again, to find your degrees of freedom for between treatments, you would do each little cell, or how many cells there are. Oh, they don't actually do cells this time, but there's 6 of them. 2 times 3 is 6. So you would just do 6 minus 1, which is 5. To find your degrees of freedom for A, you would take your factor A. Remember that factor A is gender, so it's the one on the left. I thought it was on the top. It's not. So it's 2 minus 1. Factor B is on the top. It's treatment, so it's 3 minus 1. And then your A-B interaction is just your factor A, factor B added together, subtracted from your between treatments degrees of freedom. Alright, and then your within treatments degrees of freedom, again, is each little cell, or, each little whatever, little row or column of 3. So you take each of those degrees of freedom and add them all together. So, hopefully you got that. And then your total is just capital N minus 1, which they gave you capital N. Woo! Alright, to find your MS of factor A, you just do your sum of squares of factor A divided by your degrees of freedom, factor A. Same for all of them. all of the MS's. And then to find your f, again, it's your MS of whichever factor you're finding divided by your MS within. Alright, so then they want you to find your criticals. So each critical point has different degrees of freedom, right? So if you're finding your f critical for A, you would use your degrees of freedom being 1 for the top and your degrees of freedom being 12 for the bottom. So on all of them, they're all going to have the same bottom, like the same left column degrees of freedom, because you're always using your within. It's just going to vary like how far. So you're going to type all those in, and I'm pretty sure there's a main effect if your f is bigger than your f critical value. I only found one that was bigger, but if you didn't do 6 and you did 3, like I think you're supposed to, which I'm going to do, I think that you will find more. Anyway, eta squared. So I'm just gonna give you the formulas for these because it's not hard. I think the theory behind it is kind of hard, but I don't know. I just have the equations. So to find eta a squared, the formula for that is the sum of squares of a over sum of squares a plus sum of squares within. Eta b squared is sum of squares of b over sum of squares b plus sum of squares within. And theta of a and b squared. Guess what it is? Guess what it is, guys? Sum of squares of a and b interaction over sum of squares a and b interaction plus sum of squares within. And that, my friends, is the end of that. Hopefully you have a nice day.